everyone, let me introduce myself. My name is Eriska Dinda Setianingrum. You can call me Eriska with student number K1324028. Here, I want to invite all of you to learn about logarithms. First of all, let's understand what is logarithms. Logarithms is the inverse of exponentiation, which is used to find the power or exponent of a given base number. In short, by studying logarithms, we can find the exponent of a number when we know its result. Also, it's important to know that logarithms is not only used in mathematics, but also in other fields such as determining the order of reaction in chemistry, calculating the sound absorption coefficient in acoustic, and many more. Once you understand what is logarithms, you also need to know that logarithms have a general form. What is the general form of logarithms? Let's see the general form. If a to the power of n equals x, then log base a of x equals n, with a is the base, provided that a greater than 0 and a not equals 1. X is the numerous, provided that x greater than 0. Then n is magnitude of power or value of logarithm. Let's take a look at an easy example first. Number 1. If 3 to the power of 2 equals 9, then in logarithmic form it becomes log base 3 of 9 equals 2. Number 2. If 2 to the power of 3 equals 8, then in logarithmic form it becomes log base 2 of 8 equals 3. Number 3. If 5 to the power of 3 equals 125, then in logarithmic form it becomes log base 5 of 125 equals 3. Okay, then logarithms also have properties that you need to understand in order to solve logarithmic problems. 1. Properties of logarithms of numbers 1. Log base a of 1 equals 0. Why? Let's take the example of log base a of 1 equals x. So we have a to the power of x equals 1. Any power assigned to a number other than 0 whose result is 1 is 0. So, a to the power of 0 equals 1, provided that for all bases a not equals 1. So, the logarithms of 1 for any base other than 1 is 0. This is because a to the power of 0 equals 1. 2. Properties of logarithms of the same base. Log base a of a equals 1. Why? base a of a equals x. So we have a to the power of x equals a. To fulfill this equation, the value of x must be 1. So, log base a of a equals 1. So the logarithms of a number with the same base is 1 because a to the power of 1 equals a. 3. Properties of logarithm of multiplication. Log base a of b times c equals log base a of b plus log base a of c. This property states that the logarithms of the product of two numbers is equal to the sum of the logarithms of the two numbers. Example, log base 2 of 8 times 4 equals log base 2 of 8 plus log base 2 of 4. Log base 2 of 32 equals 3 plus 2. So we have log base 2 of 32 equals 5. 4. Properties of the logarithms of division. Log base a of b over c equals log base a of b minus log base a of c. This property states that the logarithms of the division of two numbers is equal to the logarithmic subtraction of the two numbers. Example, log base 2 of 8 over 4 equals log base 2 of 8 minus log base 2 of 4. Log base 2 of 2 equals 3 minus 2. So we have log base 2 of 2 equals 1. 5. Properties of power logarithms. Log base a of b to the power of m equals m times log base a of b. This property states that the logarithms of a number is equal to the exponent times the logarithm of the number. Example, log base 2 of 8 to the power of 3 equals 3 times log base 2 of 8. Log base 2 of 512 equals 3 times 3. So we have log base 2 of 512 equals 9. 6. Logarithm plus chance properties. Log base a of b equals log base c of b over log base c of a. This property allows us to change the base of the logarithm using the base chance formula, where c is the new base chosen. Example, calculate log base 2 of 8 using base 10. Log base 2 of 8 equals log base 10 of 8 over log base 10 of 2. equals 0.9031 over 0.3010 equals 3. Second, properties of inverse logarithm of numbers. Log base A of 1 over b equals minus log base A of b. This property states that the logarithm of the inverse of a number 1 over b is the negative of the logarithm of that number. Example, log base 2 of 1 over a equals minus log base 2 of a. So we have log base 2 of 1 over a equals minus 3. After getting to know the properties of logarithms, let's move on to practice problems. What is the result of log base 5 of 3 times log base 9 of 125 plus log base 5 of 625 divided log base 3 of 81 minus log base 3 of 9. Okay, log base 5 of 3 times log base 9 of 125 plus log base 5 of 625 divided log base 3 of 81 minus log base 3 of 9 equals log base 5 of 3 times log base 3 to the power 2 of 5 to the power 3 plus log base 5 of 625 divided log base 3 of 81 minus log base 3 of 9 equals 3 over 2 times log base 5 of 3 times log base 3 of 5 plus log base 5 of 625 divided log base 3 of 81 over 9 equals 3 over 2 times log base 5 of 5 plus log base 5 of 625 divided log base 3 of 9 equals 3 over 2 plus 4 divided 2 equals 11 over 2 divided 2. So we have 11 over 4. Okay, I hope you understand. Now try to test your ability with the following exercise questions. What is the result of log base 5 of 16 times log base 2 of 5 plus log base 64 of 8? I think think that's enough. I hope you understand this material. Thank you and God bless you.